So the NH2 group, the amino group, has a relatively low priority. So many times the NH2 is named as a functional group and some other functional group is given precedence. So for example, if we look at these four compounds, all that have NH2, on the far left we see 3-aminopropanoic acid. Any compound that has a carbonyl group in it, that's C double bonded to the oxygen, that carbonyl group will always take precedence over the amine, and so that NH2 will be just called an amino. So this is a carboxylic acid, and the amino is on the 3 carbon. Alkenes also take precedence over the NH2 group. So this compound here is called 1-butene 3-amino. And again, the alkene has precedence over the numbering. We always give the alkene the smallest possible number. We've seen aniline in previous chapters, and if another group is bonded to that nitrogen in aniline, we still use that N standard or process to indicate that something else is bonded to that nitrogen. So here we have aniline, but that nitrogen is bonded to a methyl, so we call it N-methylaniline. And if it was a tertiary, if there were 2 alkyl groups or 2 other groups, it would be NN, whatever those groups were. Alright, so let's take a look at problem 16.31. We have 2 structures here. You're asked to name the following amines, identify them as primary, secondary, or tertiary, and then I think it'll be helpful to have table or figure 12.3 here because it has some of these alkyls that we haven't seen too much of, especially the butyl group, so that may be useful in this problem. So pause the video, see if you can name them. So A, we can see that it is a tertiary amine because it's bonded to 3 carbons. And we know 2 of them are methyls, but this other group has 4 carbons and it's bonded to the nitrogen in the 2 position. So when that is the case, that group is known as a sec-butyl. So this first structure is known as NN-dimethyl sec-butylamine, and it is tertiary. And then B, we just saw on the previous slide, is a secondary amine. The nitrogen is bonded to 2 carbons, and we will call this N-methylaniline. One place where we see amines a lot is in proteins because proteins are polymers made of amino acids, and amino acids always have an amino group. And on this slide we have the general structure of amino acids. They always have a carboxylic acid group bonded to a carbon, and to that same carbon is an amino group, NH2. Also to that same carbon is a hydrogen, and then to that same carbon is some side chain. That is what distinguishes the amino acids from one another. And we can see that as long as that R group is not a hydrogen, then this is a chiral carbon.